Selecting the right printed circuit board material is crucial for high-frequency and radio-frequency applications. Rogers Corporation offers high-performance laminates like 4350B and RO4003C, known for their electrical properties, mechanical stability, and thermal performance. These materials set industry benchmarks, ensuring optimal performance and reliability in advanced radio frequency designs. Rogers materials excel in high-frequency designs due to low dielectric loss and stable dielectric constant. They offer high thermal conductivity and low moisture absorption, making them ideal for radio frequency circuits, antennas, and advanced communication systems. These properties ensure superior performance over traditional FR4 substrates, crucial for demanding radio frequency and microwave applications. Rogers 4350B is a glass-reinforced hydrocarbon ceramic laminate offering superior electrical performance with a dielectric constant of 3.48 and dissipation factor of 0.0037 at 10 GHz. It ensures ease of processing, excellent thermal reliability, and cost-effectiveness, making it ideal for high-frequency circuits and power amplifiers. Its compatibility with standard FR4 processes enhances its appeal. RO4003C is engineered for commercial high-frequency applications featuring a dielectric constant of 3.38 and a dissipation factor of 0.0027 at 10 GHz. It offers low dielectric loss, an excellent cost-performance ratio, and high reliability. These attributes make it ideal for broadband, low-loss applications, providing a cost-effective alternative to traditional materials. Comparing Rogers 4350B and RO4003C, the key differences lie in dielectric constant and dissipation factor. RO4003C is more economical, ideal for low-loss applications, while 4350B excels in thermally demanding scenarios. Both are FR4 compatible with similar Underwriters Laboratories ratings, making them versatile for various radio frequency and high-speed digital applications. Rogers 4350B and RO4003C are pivotal in telecommunications, automotive radar, aerospace, and medical imaging. Their properties support high-speed digital and radio frequency signal transmission, making them ideal for satellite communication antennas and phased arrays. These materials excel in applications requiring stable performance and reliability in demanding environments. Manufacturing with Rogers materials demands precision due to their unique properties. Handle materials carefully to prevent damage. Use vacuum lamination for multi-layer boards. Adjust drilling, plating, and lamination processes for optimal results. These steps ensure the integrity and performance of high-frequency and radio-frequency applications, setting the stage for hybrid printed circuit board stack-ups that combine Rogers materials with FR4. Hybrid printed circuit board stack-ups integrate Rogers materials with FR4 to balance cost and performance. Key factors include managing coefficient of thermal expansion mismatch and setting appropriate lamination temperature profiles. Bonding films must be compatible with both materials to ensure reliability, crucial for maintaining structural integrity and performance in high-frequency applications. Design considerations for Rogers materials focus on precise impedance control and signal integrity. These materials reduce insertion loss, crucial for high-speed designs. Their higher thermal conductivity aids in thermal management, especially in high-power radio frequency designs. These factors are essential for optimizing performance in advanced radio frequency and high-speed digital applications. Challenges with Rogers materials include higher costs and special handling requirements. Limited availability and tight process tolerances are also concerns. Collaborating with experienced manufacturers is crucial for design success, ensuring optimal performance in radio frequency applications. Selecting the right manufacturer is crucial for radio frequency microwave printed circuit board success. Opt for those with proven experience, in-house impedance testing, and hybrid stack-up support. ensure they have certifications and robust quality control to maintain consistency. This ensures the reliability and performance of Rogers materials in high-frequency applications. Rogers 4350B and RO4003C materials are pivotal for advancing radio frequency and high-speed digital designs. Their exceptional properties cater to diverse industries, despite higher costs and fabrication demands. Mastering their advantages and processing intricacies empowers engineers to harness their full potential in cutting-edge applications.